So this week we're going to talk about flow control. And flow control is kind of how we write code that will allow our code to go from a start all the way to an end, all right? And there's usually some checks and things that we need to do along the way. So if we look at this flow chart that we have here, you can see where we start up in the upper left, and we ask a question like, is it raining? Yes or no, right? If yes, then do we have an umbrella? If no, then we're going to have to wait a while, and we'll ask the question again, is it still raining? If the answer is no, then we can go outside and end, right? And so you get all these different loops, but you have all these different checks and balances. Your programs are going to need something very similar. So these flow charts, you can think of this yes and no as a Boolean value. If it's yes, it's true. If it's no, then it's false, right? So is it raining? No, false. Then we can go ahead and go outside. All right. These flow charts can make things a lot easier when you're building out more complicated projects. I don't recommend that you build one out for the entire project, but you may want to build something like this for your midterm to get you started and make sure you're not missing any checks or balances that you may need. Out here in the module section, you'll see this diagrams.net. This is a free tool you can use to build out those flow charts that you saw inside here. So I can drag those in and I can build out my own flow chart just like what you see here. All right. I used to make you guys do that as a homework assignment. I don't have that anymore. All right. So Boolean values, you heard me say true and false. So we have data types of integer, which you guys remember from last week. We have floating point, and we have string data types. And those all have an unlimited possible number of values, right? It could be -1, could be 1, 10, 1,000, a Google, whatever it is in between, right? A Boolean data type is only going to have two values. It's either true or it's false, right? Boolean data types are always capitalized, meaning that a capital true is different than a lowercase true, all right? So make sure your capitalization is correct there. Otherwise, it's two totally different things in Python. So when you enter Python code, Boolean values will have true or false, and they'll lack the quotes around the strings. What that's essentially saying is if I have spam equals true, and then I check the value of spam, I'm going to get back true, right? If I do lowercase true, I'm going to get an error on the line because true at that point is now a variable. It must have a capitalized T, right? And if I say true is equal to 2 plus 2, nothing's going to work there because I can't assign this to a true value, right? Anybody have any questions on Boolean values? Again, Boolean values, there's going to be a change here. You'll have Boolean values and you'll have Boolean operators. Boolean values is the value. It's either true or it's false. Pretty simple. All right, to get true or false, we have to have comparison operators, all right? We also call those relational operators. And essentially, we're going to try to take two values, and we're going to evaluate that down to a single Boolean value. So if we have equals equals, if you look at the operator of the equal sign, that is asking whether it's equal to. If we have an exclamation mark and an equal sign, is that not equal to? Less than, greater than, less than or equal to, or greater than or equal to, all right? If we are comparing string values, we can only use equal to and not equal to, right? I can't see if Jason is greater than Sam, right? That doesn't work. They're not math. So I can only check to see if Jason is equal to Sam or if Jason is not equal to Sam, right? Same way with the greater than, then I can do something like is 4 greater than 5 or less than 5 or less than or equal to or greater than or equal to. So in these examples here, you can see is 42 equal to 42? That comes true. If 42 is equal to 99, that is false. And we can check those in between. All right. You'll notice the only thing you can do in strings, hello is equal to hello. However, hello is not equal to a capital H for hello, right? Again, everything's case sensitive. Anybody have any questions on that? All right, you'll notice here that 42, which is a what? What data type? Integer, right? And you have 42.0 over here, which is a float, right? Those two are equal to one another. That's true, right? However, a integer is not equal to a string of 42. It's two totally different things. So you guys have used the equal sign so far and the double equal sign. This is where a lot of people will get messed up when they're writing code, especially when they do if statements, things like that. Remember that if you're asking if it's equal to, it's two equal signs. All right. If you're assigning a value to a variable, it's only one equal sign. A lot of people forget that second equal sign when they're doing these statements that we're about to do here in a minute. All right. This is also a quiz question. So note the little gray box up here at the top. It's on a quiz. All right. We talked about Boolean values, which is true and false. We also have Boolean operators. There's three Boolean operators. You have and, or not. And those are used to compare Boolean values. So we can say, is something true and true, right? Or if we're evaluating that it's going to true and true, then that equals true. If it is true and false, that will end up being false. And to understand how those work, you look at these truth tables. All right, there's three different truth tables. This one is for and. So if it's true and true, it's true. If it's true and false, it's false. False and true is false, and false and false is false. Right? In other words, both sides have to be equal to one another in order for it to work. If you're looking for and, it has to be true and true to be true. Right? Or is going to give you the opposite. So if it's true or true, it's true. If it's true or false, it's true. If it's false or true, it's true. And if it's false or false, it's false. All right. So it's got to be the opposite. The last one is not as super easy. It's either the opposite of whatever you said, right? So if it's not true, it's false. If it's not false, it's true. And you can chain them together and do something like not true, right? Anybody got any questions on Boolean operators or Boolean values? Okay. So how does that end up working? We end up using something like Boolean and comparison operators together. You guys have probably seen this back when you have done math in high school. You will have something like 4 is less than 5. Notice that's in parentheses. And that ends up being true or false? True, right? And then on the other side, we have 5 is less than 6. Evaluates to true. And therefore, we have true and true, which gives us true. All right. If either one of those sides is false, for example, in the next one, we have 9 is less than 6, then the whole thing is going to be false. All right. So that gets us to flow control. And flow control is designed to give us some condition, and that's always followed by a block of code, which is called a clause. Right. Conditions are going to be whatever expression that we go. They always evaluate down to either true or false. Okay. Blocks of code. This is where it's going to be important when you're writing lines of code. So far, when we've written code, everything's on the left-hand side, right? So if I bring up idle, I start a new file up here, and I write some code, something like print, like this. You'll notice everything has to be to the far left here, right? If I run this code, remember you need to put this in some place that you can store it. Don't store it in the main default folder. And if I evaluate that, I come back to hello and welcome to week 2. If I have this tabbed over and try to run the code, I'm going to get an error on an unexpected indent. Indents matter when you're inside Python. All right. So when it's over here to the far left, this is considered a block of code. If I put things below it, like print, what is your day look like? right? And then I get an input from a user. So we'll call it something like day. And then we can print it out. Something like that, right? So if we run this code, you can say it comes back something like that, right? That means that this entire thing left aligned is a block of code. Right? We're going to deal with other indentation. So if we look at this code here, we have something where we have a name and a password. So we could say name equals Jason. Let's do something like a password equals Python 123. And then we can see how they were using if statements to look below. All right, so we're going to talk about if blocks. If the name is equal to Jason, then print, notice how print is indented underneath the if statement. Print hello Jason. Then we can say if the password is equal to something, print access granted. We can also check for something else here. And if it is something else other than password equals something, we will say something like wrong password. All right. And I used the wrong bracket. There we go. Okay. So if we look at this simple project, we have name equals Jason. This is just the variable name and a password of Python 123. All right. If the name is equal to Jason, notice this is equal to. Is this going to come back true or false? True, right? So if it's true, then we're going to execute the next block of code right below it, right? If we put something down here, if name equals Jason is not true, for whatever reason, I put a name up here of Ben, then we're going to skip all of this code because this evaluated down to false. Therefore, we skip everything till we get back to the next line of code to the far left. So if I was to run this, we should see, of course, I keep using different ones. You should see this is the end of the program. Notice how we had nothing else printed out here in the middle. All right. If I change this name back to Jason and run this program, you'll see that hello, Jason, and we get the wrong password. And then it comes back to this is the end of the program. So the reason we got wrong password is in the next check, we run if password is equal to something, and it actually has to be the word something. If this is false, we will then hit this else statement, in which case we print out it's a wrong password, and then it goes ahead and executes this last line of code. Right? If we were to change this password to Python 123, then we should get all of our print statements of hello, Jason, access is granted. This is the end of the program. Does everybody kind of see how this works? So you can have if statements and you can have else statements. And we'll look a little bit more at that. An if statement, when it's executed, has the keyword if. It needs to have some condition that evaluates to either true or false, followed by a colon, and then the next line of code starts with an indented block. All right. So if we look at our code, we have the if keyword, we have some condition, which is this name equals Jason. Sometimes people will put this in a parenthesis here. That's fine if you want to do that. Doesn't matter. It would just come down to, is this true or false? All right. Now, we could also get another one here. We could say this is test, for example, right? And we could say print, what is your name? And we could say test equals our input. And therefore we could get the input from the user, what their name is. What's your name? Sam. Sam is just going to go straight to the end of the program. All right. If I rerun this and I end up typing Jason, then we can see it ends up executing the line of code that equals Jason. So because this was true, it will go ahead and run the rest of the code down. Yeah. Yep. So I didn't indent this. If I go ahead and try to run this now, I'm going to get an error that it's not indented on that particular line. All right. If you were to move this one over, well, then what will happen is it will test this one and print it, but then it's going to do the next check of if password. The thing is if this is not Jason, it's going to say false and skip it, but then it's going to go ahead and check the password. So because this is on the inside, Jason has to prove true first, then it will check the password. If Jason doesn't prove, we don't even bother checking the password. That make sense? Great question. All right. So simple little program here. We start, we ask if the name is equal to Alice. If that's true, we print hi Alice. If it is not true and false, we just end the program. Okay. We also have the ability to have an else statement. You can think of an else statement as a catch-all. If it didn't match anything, this is what gets caught. So in this case, you'll notice that we have an else statement here. We do not have an else statement on this if. All right. Else statements are optional. You'll notice that you just use the word else and you have a colon. You do not have any kind of condition out here that could be met. All right. It's just else and a colon. Next line has to be indented and go on down. Anybody have any questions on if and else's? If we want to check another condition, so we want to see if the password is something else, we would use what's called an elif. All right. And that elif will need a condition. So something like password equals monkey. Right. Then we could print something like that. Doesn't matter what I code in here. It will first check if the password is equal to true. If that's true for Python 123, it will print this code and end it and go straight down here. If it is equal to monkey, this will be false. Therefore, this code won't execute. It will then check the next elif immediately. If password is monkey, it will print this and then go down here. If it is not monkey or Python 123, it will catch on the else statement and print wrong password. Everybody see how if and elif chains work? Okay. I can have an unlimited number of these elifs. So I could have something like elif password is equal to something else, right? So say I say something, then it will go ahead and print something under there if I wanted to print. So print something like that. All right. You can chain these out for every possible case that may be in there. Now, you probably wouldn't do that on password, right? Because it's probably only one password for a given user. But what we may want to check is something like a different user, right? So if we wanted to check for specifically this one here, and then we may do something like elif test is equal to Sam, and then we can check against Sam's password. So we could say if password equals Sam's password, we could print that. And maybe we would have an elif here for test to equal Mary. We can check that one. And then if we did an else, this statement would be something more like, let's copy this real quick. Like that. Now, if we check this, it's going to first check to see if the test or the name they typed in is equal to Jason, right? So in this case, I'm going to remove this up here, make this name so that it makes more sense. And then we'll go ahead and put name in here. All right. So if name equals Jason, then we'll print hello, Jason. And then we'll ask or check the password. If that's true, we'll do access granted. We'll probably need to put an else statement in there if it's wrong so that we can say it's the wrong password. Same way for Sam and Monkey. We could do an else and we would print that's the wrong password. And we would print the wrong password for Mary. All right. So you'll see you have a lot of nested if statements and else statements inside the main if overall. And you can chain these all the way out. All right. The difference between running something like this and checking if it's Jason or if it's Sam or if it's Mary and doing something like just a straight regular if statement is that if this matches, it's also going to go back and check the name of Sam. And then it's going to go check the name of Mary. So these lines of code will all get checked if I use straight if statements over here on the left. If I use elif, then the first time one of these matches true, it runs the code under that and goes all the way underneath the else. So there's different times in your code that you may want to check every single one. There may be times where you just want to, once you find the first valid one, run some code, skip that part and go down to the next line. How's everybody feeling on if and elif statements so far? If it sounds like Greek, tell me. I get it. All right. This part will come with practice. So as you're running this and you're not getting output as you expect, keep practicing to figure out how if and elif statements work. This here would be considered an if statement with two elifs and an else, which so happens if you looked at this homework assignment, we need to have an if statement that must contain two elifs and an else. All right. Note that if statements need a condition and a colon, and then some block of code underneath of it. We do not have to have an else, so you don't have to put one on there if it doesn't make sense to have one. You do not have to have an elif if you don't want to, and you can have as many of elif statements as you want. You can only have one else statement. Does that make sense? There's only one catch-all for else. But you can have as many elifs as you want. Again, that's going to be on a quiz. All right. Anybody have any questions on if statements? All right. So if we look at this code and we run this, and let's see here. Aha. I used a single equals statement here. That will cause a problem, right? Because if I'm doing this, I'm assigning name to the word spam. I have to have a double equal sign in order for it to check to see if name is equal to Sam. All right. That right there is usually one of the most common mistypes when you're using if statements, etc. So if I run this, what's my name? And I say Jack, it will say, I do not have you in my system, and it will end the program, right? Again, if I rerun that code, and I say Jason, and then it finds that my password was correct and goes in, you may want to edit your program now instead of having password hard-coded. It would make more sense to ask for the password, right? So you could say something like print, or we could just do an input, password equals input. Something like that. And then we can do a check. And of course, we're going to have to add this before every single one of these times that we check against a password, right? So now it's going to ask for Jason. Then it's going to ask me what the password is. And unless I type in the right one, I just say password. Then it's going to say it's the wrong password and end the program. Well, it'd be nice to give them more than one option to type in the password, right? So the way this is written is they can only type it in once. If it's right, it's granted. If it's not, prints wrong password and skips all the way to the end. So what would be nice is to loop them over and over and over until they type in the right password, or maybe after 5 times we kick them out of it, something like that, right? That's where we would use something like a while loop. So a while loop is going to keep us in a block of code until it evaluates to true, right? So how does that work? We would have something like while true, which means that loop is going to go on forever. So it has a condition here, and we could say something like name equals Jason. And while name equals Jason, then it's going to run this line of code. If it does not equal Jason, it never runs this code. Okay. If we say something like while true, well, then it's going to be in a forever loop inside this code. Okay. Why would we want something like that? Well, now we can check to see if it's Jason. And once they have it's granted, we can use things like a break statement to break out of this loop. They put in the right name. They also put in the right password. We can break them out. Make sense? If they gave us the wrong password, we can use something like a continue statement to start this loop back over. Now notice I put the name outside of this while true, which means we're going to gather the name from the user, but we're only going to keep them in a loop until they give us the right password for that particular user. If that name does not equal somebody in the system, that might cause some problems. So if we run this and I say my name's Jason, and it'll say what's the password, and if I type in something, I will be forever stuck in this password loop until I answer it correct. If I say password 123, access is now granted and it hits the end of the program. So a while loop will allow us to sanitize input. If you guys remember from last week, you guys had to ask for a name or a age or something like that, right? But they could type in gibberish and it would cause the program to crash. So if we want to, quote, sanitize those inputs, make sure that what they type is something that we wanted, we can use a while loop to do that. We put them in a while loop, and they would have to sanitize that password, for example, in here in order to get that out. Now notice they are stuck in there. There's no 5 count or something like that, once they hit that count, we kick them out. We could do something like that. We could do count equals 0. And when we do a while true, we could say while count is less than 5. All right. Which means count is currently at 0. Then when we went through here and on the break on the wrong password, we could do something like count equals count plus 1. So when they get a wrong password, we're going to add 1 to the count. All right. We'll need to add this same code to all the other options down here. So if we add this down here, we need to take our break. If it's right, we'll add a break. This one, add a break, and a count to go down here. All right. Once that count equals 5, or in this case, as long as it's less than 5, then it'll keep us in. So if I run this code and I do something like Jason and I do this, didn't work. Anybody know why it didn't work? Here. No, we're assigning the value of count and we're taking count and adding 1 to it. Yeah. So good question here is on this continue, what that does is start this loop all the way back over. Well, because this continue is starting the loop all the way back over, this code never gets executed. All right. So we'll want to flip this where the continue is underneath us adding the 1. Now, you don't have to have continue in there. Continue is actually implied. So you can leave the continue in, you can take the continue out, it doesn't matter. For your homework assignment, it requires you to put the continue in there, at least for the first one. All right. So when we go ahead and run this one, the idea is we have Jason. There you go. At the point count equaled 5, in which case 5 is not less than 5, it went ahead and ended the program at that point. Everybody kind of see how a while loop works? It will keep us in that loop until this is false. As long as this is true, this loop will continue over and over and over. It would work the same for Mary or anybody else. So if I am Mary, it's going to ask for the password for Mary. And if I give it 5 times, it will go ahead and fail. Now, why does it work on 5? Well, that's because I started at 0 and I said as long as count is less than 5. So the first time this runs, this will be is 0 less than 5. Yes, it goes ahead and execute. Then it's going to say is 1 less than 5, 2 less than 5, 3, 4. Once it hits 5, it kicks it out. All right. If I wanted to say less than or equal to 5, then it would give me how many options? 6, right? Because we started at 0. Okay. If I put in a name that's not in the system, well, then I have a problem because now I'm stuck in this infinite loop, which I need to stop before it crashes everything. If you get yourself stuck in an infinite loop like this, you can click the X at the top and you can close it. It's better to hit Control-C on your keyboard, and that will end up stopping the loop inside of there. All right, Control-C. My problem is I let it run on too long, and so now I got to close it. Okay, if you break it, it's broken. You'll have to go back in. So why did I get stuck in an infinite loop? Let's look at the code. It's because this was greater than 5, right? So we start off running the code. Then it comes down here and we have this else statement that says, I don't have you in the system. Well, because we're never adding 1 to a count, and because the name doesn't exist to any one of these, I'm forever stuck in that infinite loop. So it's probably not a good piece of code. We would want to make sure that before we start this while loop, that it is one of these valid people. So instead of doing a while count on every single one of these, we should break this down where the while count is just for the individual user. So if I highlight all this, you'll notice I need to move this over to the left. If I highlight all of it, go to Format, and then Dedent, it's going to shift everything over to the left for me. Okay? Very handy when you're dealing with giant blocks of code like that. So now, once we have a valid name of Jason, instead of them right before they type in their password, we're going to use this while count, and we'll put password over, and then we can go ahead and check to see if that password's right. If it's not right, it's going to keep them in this loop till it's over. And we would need to do the same thing for every single one of these other people. So while 5, we can keep it in, and Mary, while count is less than 5, we go in. All right. Now, if it is not one of these names, Jason, Sam, or Mary, it just prints, I don't have you in the system, and goes to the end. And we can go ahead and test that. If I try to be Jack, I don't have you in the system, and it ends. If it ends up being Jason off the top here, then I have 5 chances to get it right. If it's wrong, it'll end the program. How are we doing? Everybody able to follow along with what we see so far? Again, build these silly little programs because that's the easiest way to figure out how this all fits together. Okay. So when you work on this homework assignment on Wednesday, I'm going to walk you through an example of how you would do that homework assignment. Take that example, but do something completely different with it so that you can understand what's going on. Because I can tell you this over and over and over. I can even give you the answers to the homework assignment, but I can't give you the answers to your midterm project, right? You got to know how it works at that point. And we're not going to use ChatGPT and all the other bad things out there for that, right? Please don't do that. Not for this class. All right. So when we look at these, we have our while statement. We talked about these same conditions, same exact things. Let's see. You have the annoying loop, which is kind of what I already showed you guys. So if you looked at this code, while name is equal to nothing, and it says while name is not equal to your name, please type your name. And as you type in your name, et cetera, you're going to be stuck in this same loop over and over. Why would you be stuck in this loop? Based off this code you see on the screen. Whoop, too far. If I type in Jack and Jason and Mary and Sam, why would I be stuck constantly being asked what my name is? Until you put in what? Yeah, exactly, right? The idea is it says, please type your name. It's not asking for Jason, Sam, Mary, Becca, whatever. It's making sure that you only type in the phrase your name. If it doesn't match that, you're forever stuck in there. Okay? So what does this little silly example explain? Anything you put in there, it has to match exactly that, or you never get out of that loop. All right? Unless you have a break statement or something else to get you out of there. All right? Let's look at this. Should get us there. So we talked about break statements. You can use a break statement inside of a while loop. You can also use them inside of a for loop we're going to talk about here in a little bit. A continue statement, you really don't necessarily need a continue statement unless you want that loop to start over. So if you remember inside of our code here, because I had this continue in front of the count, this line of code never got executed, which means you always want your break at the end of it, and you always want your continue at the end of that block of code. Okay, if you put it anywhere up above it, none of that code below it's going to get executed. You do not have to have a continue statement. It will automatically start the loop all the way over if you do not have a continue statement. But remember, for your homework, you will. If you get stuck in that infinite loop, use Control-C on your keyboard to break you out. If you wait too long, you're going to see what you saw on my screen, and the application will just crash. Okay? Let's see here. What else we got? All right. So we talked about a while loop. We talked about if, elif, and else statements. The last option that you have is a for loop. So a for loop, you're going to use the keyword for, and you're going to set some variable name. You'll use the in keyword. In this case, we're going to show you how to use the range method, and we're going to pass up to 3 integers in that, and then have a colon. So what does that really look like? If we look at this one, we print my name is, and we're saying for I in range of 5. Now, I is just a variable. We can have I, A, B, C, D, whatever we want. We could have for letter or for number in range. It doesn't matter what variable name we put there. It's just that that variable name is what we'll use in the line below it. So for example, if I say for I in range of 5, what that's going to do is start at 0 and it's going to go up to 5, but does not include 5. Okay. What does that all mean? Let me just steal this code. Let's go look at our program here. I'm going to highlight all of the stuff that we had before. I can go to format and I can go to comment out region. This allows you to comment out all of that code that you had before. This can be helpful if you have a bunch of scratch notes or a big block or some piece of your code isn't working, comment it out. That will make sure that that piece doesn't get executed. All right. So if we look down here, we have for I in range of 5, Jimmy's 5 times, go through there. We can run. And we will get Jimmy 5 times 0, 5 times 1, 2, 3, 4. How did we get that? If we look here, we took I. So the first time through, this number is going to be 0 because it always starts at 0. All right. It goes 0, 1, 2, 3, 4. It goes up to 5, but does not include it. This is going to get a little bit tricky in Python. There's going to be things that go up to, but does not include. There's going to be some that go all the way to and include. All right. So as I'm teaching you these, make sure you remember which one's which. Range goes up to, but does not include. So when we print this out, we're taking I, which is a what at this point? Starts off at 0, 1, 2, 3, 4. What is 0, 1, 2, 3, 4? Integer, right? So range is going to give us back an integer. The first time through, it's a 0. We need to convert that to a string so that we can put that inside of our print statement. And then when we execute this code, it executes it that many times, right? So let me just shrink this up here. You can see we got 0, 1, 2, 3, 4, right? Notice 5 times it was out printed, but because it always starts at 0, it goes up. All right, now this range command has 3 different placeholders that you can put information in. If I put in this first one, it's where it's going to start. So 1, 5 means I start at 1, I go up to 5, but not including 5. So now if I run it, the output starts at 1, it goes up to 5, but does not include 5. Okay. If I go to, say, 10, then I should get 1 through 9. Again, it goes up to 10, but does not include. If I wanted all the evens inside of there, for example, right? Well, I would start at 0, and I can either put the 0 there or leave it, doesn't matter. If I do 0, 2, so now I have 0, 10, 2, that's going to give me 0, 2, 4, 6, 8, stops at 10, right? Does not include 10. Therefore, if I wanted 10 included, I would have to do 11. And now I would get 0 through 10. If I wanted to always start at 2s, now I get 2, 4, 6, 8, 10. Right? If I want odds, I would do something like maybe every 3, or I could do every 2, but I would have to start at what? You guys count the odds from 1 to 10. Where do you start? 1, right? You guys are thinking way too hard on that. All right, we got 1. We run it. Now we get 1, 3, 5, 7, 9. Okay. In this for loop, you're going to set a variable. It doesn't matter if you use I, we could call it number, in which case we need to just change this variable name to number. The exact same output comes through. It's whatever you define here is what you need to use inside that block of code below it. The for loop is going to only go through a finite number of times. Remember, a while loop is going to go indefinitely until that condition equals true. In a for loop, it's a very finite number of times. In this case, we say everything from 1 to 11 and count by 2s. If I wanted to count by 3s, I could do comma 3, etc. Right? If I say start at -1, it's going to start at -1 and count on up. In this case, it's doing it by 3s, right? Does everybody have an idea of how for loops work now? You also have the range command. So far you guys have dealt with print statements. You've dealt with input statements. You've had the string function. You've had float functions, integer functions, and now you have the range function. Okay. If I leave any one of these out, for example, I take that -1 out and I hit run. Well, now we got a problem because now it thinks it wants to start at 11 and it wants to go up to 3. That won't work, right? So this number on the left has to obviously be smaller, and we would go 0 to 11, and it will hit those placeholders. If you forget how those placeholders work, if you just come down here and start typing range, wherever it is, come here, range, and stop right after that, you're going to see this pop up here. Let me get this better on my screen so it gives you the actual code. You can see it's asking for the start, the stop, and then the step. And the step means I want to go by 2, 3, 4, whatever you want to step by. Okay. Everybody understand this range command? In this case, the range function is what we call it. Again, this will be on a quiz. It's the reason I'm talking about it like 4 times, is to make sure you understand how that works. So what is the first one? It is where you start. The second one is where you stop. The third one is the step value. All right. That gets you a for loop. You can set it up however you want. It just keeps them looped through all the time. You can write an equivalent while loop to make it equivalent to a for loop, which is exactly what we did before. So if we say while I is less than 5, then we say I equals 0, and we do this little counter at the stop. Okay. For loop's a whole lot easier because I could just say for I in range of 0 to 5, and then it would just do it 5 times. I don't even have to use the output of what comes out of here. So if I say for number in range of 0 to say 11, and I don't even have to do this, I can just print whatever I want. Yippee. Something like that. Let's take out this extra one. And if I run this, I will get yippee 10 times. Notice it didn't ever print the number or anything it just did. It's just going to loop through it however many times I told it. Because I never used this number variable down here in my code, doesn't matter. It's a great way to have it loop through a certain number of times. All right, we talked about this part where the range command, where we tell you the different ones. Anybody have any questions so far? I know this is a lot of new code, language, frankly, gibberish for a lot of you that have never seen anything like this before. All right. The best I can say is practice writing some test code. Okay. Practice on those homework assignments. That's the reason I leave them open-ended. I should not have the same homework assignment from you that I have from her. Should not have the same over there and over there. Make them your own. You have to make them funny. I don't care. Please, I'm grading 75 of these. Make them humorous. I'm a funny guy. I like a little humor in there. All right. Just don't go beyond humor. All right. I had a student one time that was quite offensive in some of the homework assignments he was doing. To a point it was not comfortable. So don't go that far, but have some fun with them. All right. Python has a bunch of built-in functions. You guys have played with those so far, right? The print function, the input function, the len function. Does anybody remember what len does? Yep, calculates the length of whatever string that you give it. All right. We also just learned the range command or range function. Those are all called functions. All right. Those are all built into Python. That's part of its standard library. It also has a ton of other libraries that we can import into our code so that we can do a bunch of other cool stuff. All right. So the next one we're going to talk about is importing the random module. Anytime you import a function or import a module rather into your program, you always have to do that at the top. Okay. So we say import random, and that gives us access to the random module. And the random module has all sorts of different functions to it. If we type random down here and hit dot, it will give us all the different options of what's available inside random. Okay. The one we're going to learn about is rand int. So if we go over here, you will see this one called rand int. And rand int is going to give us a random integer. So we want to return something between the range of A and B. In this case, it's going to include B. So if I want a random number between 1 and 10, I would do something like 1, 10. All right. And we could say this is a number. And we could then print our number, whatever that may be. So if we run this, we got a 5. If I run this again, I get an 8. All right. It just randomly picks a number between 1 and 10. It includes 1 and it includes 10. So don't confuse this with the range command, which goes up to and not include. This one includes. Okay. So say I want 5 random numbers. I could do for I in range of what? What do I type in for the rest of this? I want 5 total instances. 0, 5 works. And then I can tell it to print this. Because the first time it goes through, it creates a random number, then prints it. The next time it comes through, it creates a random number and prints it. We should get 5 random numbers. 10, 1, 3, 7, 6. All right. Anybody have any questions over how random int works? All right. So again, you pass it the options. It tells it what it would go through. That one's built in. There's a couple other ones in randint that you guys could use. Random itself has ones that some students will use over time. So we have random. We'll talk about them in the future, but for now you can see it. We will use random int, which gives us a random integer. Sometimes a student will want to use something like choice. So if we had a bunch of options and you wanted to pick a random choice out of those options, you could use random choice. Don't worry about that one yet. That'll be a little bit down the road after we learn lists. All right. Other modules that you may want to import would be something like import sys that accesses the system. Ones that we would use inside sys is going to give us something like sys.exit. So if we want to end our program right away for the user, say they got something in, we don't want them to execute any more code, we would call sys.exit, and that will end the program right then and there. Okay. Remember, always try to run your imports up here at the top. Like that. Okay. The book is going to tell you something like this. You could import 4 different modules like import random, sys, OS, math. We'll talk about these other modules. If you are importing them, always put them on their own line. All right. You can do what the book says here. However, in new PEP 8 compliance, they want you to do it this way. So always put a random module or a module on its own line when you import it. This will help you when you get to the final project, when we have something special that we do with those modules. All right. If we don't want to import the entire random module and all we really want is that random int function that we've been playing with, we can use from random import rand int. And that will just bring that one function over as opposed to the whole module. All right. You guys are coding on computers. It doesn't really matter if you bring over the whole random module. The difference between the two is if I want to call for a random integer now, I can just call rand int 1, 10. I do not need the random dot in front of it. Okay. If I say from random import rand int, I just call rand int and that's it. If I go the other way and say I want to import random, well, then I need to put random dot whatever function I want to execute. Okay. There's a reason to do both. If you're building a really, really big program and you only need the one function out of that module, you'll never use another one. It makes sense to only import the one module. It saves space in memory. All right. If you guys were working on little embedded controllers, you guys wanted to build the cool little light shows that you see at Halloween and things like that, where they're, or Christmas light displays where they're going to music, those run on little embedded controllers. You only have so much memory. You guys are on computers, you can import the whole module. Anybody have any questions on importing modules? You can import the whole module, or if you just want to import a function from it, from random, import random. And that will import just the one function out of there. All right. Again, the main one that we would use from sys is using sysexit. So if you look at this code, we would say print type exit to exit. If whatever they typed in was equal to exit, then we would go ahead and immediately end the program. If they typed anything else, we would just print whatever they typed back. That's what this program does. Okay. In this case, because this whole thing is in a while true, this program will never end until they type exit, at which case it will go ahead and end the program. Anybody got any questions on other modules? Anything else? Again, we'll use OS and math and some of the other ones later on. All right. You have this little program here where it's going to have you guess the number game. All right. We're going to do something similar for homework 1. So we'll wait on that till Wednesday. You could also build out a short program of rock, paper, scissors. I encourage you guys to go through these 2 assignments or these 2 little practice programs, because that will help you understand all of this that we're putting together. Okay. On Wednesday, we're going to go through the homework assignment. So you can get started on it if you want, or you can wait till Wednesday and we'll go through the homework assignment. Also, at the bottom of these, you're going to see something like a summary. Then you'll have practice questions. Try to answer these. If you can answer them, then you probably know the material. You don't have to fill anything out or anything like that. If you're questioning yourself and you don't know whether or not you understand it, just quickly run through these practice questions. There will be a time when they'll have practice projects down here and you guys can run through that, where it doesn't give you the answer. You have to figure it out. Okay. Anybody have any questions over the material today? If you're stuck, please keep going through it. If you want, go back and watch the module videos from last semester, year before, whatever. All right, stop the recording.